next topic is about the best science class and how science teachers can boost uh, the students' science scores. So CBEST says that the best way for teachers to boost the students' science test scores is to stop worrying quite much about the scores and start being concerned about making the students excited by science. And my introduction says the best way for a teacher to increase the student's test score is to stop worrying in classroom only, just to stop working in the classroom only and have some fun in the lab. Before everyone graduates with the best score in science, the teacher should at least once have a demonstration in the classroom with the following field trip. Moreover, teachers should let student experiment by themselves, allowing them to make project proposal and observe experiment in the lab. Before ever asking students to memorize facts, the teacher should demonstrate a scientific process, or better, teach the student how to experiment for themselves, allowing them to apprehend the process with their senses before trying to fix it in their own intellect. So basically, what they're trying to say is that you cannot teach science without lab experience. You must have at least one experiment for your entire biology class or chemistry class, or you are not full about science. You don't have the best science score. And for example, what's the best writes? For example, the teacher might pass around an ant farm in the classroom. They don't blow themselves up before asking them to memorize the formula. Oh, hold up. The ant farm in the classroom in order to... And let the students observe the little critters skittering behind the glass, going about their complex individual tasks, before asking the students to read that ants have a rigid social structure, just as people do. If possible, it would be even better to take them on a field trip to observe a real ant hill or to see how other kinds of real animals behave, say on a farm or in a zoo. The teacher might allow the students to create a chemical reaction in the beaker, taking care of course that they don't blow themselves up before asking them to memorize the formula. So basically, I was really lucky because I was really outgoing as a kid, and observing an ant hill for me is not a problem at all. I think when I was really, really young, once I went to the forest and I saw an ant hill. It was so impressive that I wouldn't even go back to that. So basically, I see ants all the time. Well, the more interesting for me were when I saw the beehive. So I decided to write about the beehive in my essay. And I write, as an example, the teacher must show beehive on the movie projector or beehive farm and let the students observe how bees crawling on the comb, skittering on the glass, going about their business. I don't know if I can write about business, but I think it's okay. Then let the students read about bees' rigid social structure. If possible, take students to the field trip to see the real beehive, wear protective beekeeper equipment, observe them in the wild. Another example is how the teacher creates chemical reaction on the board, then demonstrates it in the beaker before students try it on their own to help to memorize the formula. So basically, it's very hard to memorize the formula just by writing formulas on the board. So basically, And then other experiment, other experience what I had was, for example, what's the best friends? When I was small, I had first-hand experience this kind of teaching. My father built a telescope, a painstaking project that should only be taken out of love because it is a very difficult, intricate task. I recall that even he swore a lot during that period. The telescope had a clock at its base that kept it fixed on the moon or stars rather than turning as the Earth turns. When my father switched it off, the clock, I remember watching through the eyepiece, fascinated how quickly the stars drifted out of my field of vision. It took only seconds, and even more fascinated to realize that what I was seeing was us floating so swiftly through space. He told me um, the magical names of the geological formations on the moon, such as the crater called the Sea of Tranquility. When I looked through the lens, the pock-marked silvery disk of the moon seemed as close as the hills behind our suburban house. After that, I became interested in the statistics that, such as the rate of the rotation of the Earth, the geophysical facts behind the making of the craters that form the moon's lapping phase in a way I never would have if the facts had been the starting point of a lecture. And what I write. When I was a kid, I had hands-on experience with this kind of teaching. My father owned his own microbiology lab. The microscope he had a small mirror, and I could play with light and less magnification to adjust the slide. My father helped me to pick up the sample with the scraper, and I was fascinated to see floating fungi, bacteria, and protozoas from the local pond. I could also see human tissue samples. I was taught that human skin had three layers, and when a person has a blister, the upper layer is detached from the skin. After that, I became especially interested in natural sciences, such as microbiomes and their influence on human well-being. That way, I could never forget the facts about microorganisms and human tissues. This approach should be begun not in high school or college, but in grade school or even in kindergarten. The facts are important, of course. Without them, we can have no real understanding. But curiosity is as vital to learn as the ability to memorize, perhaps more so, because curiosity will keep students learning long after they pass the final test in school. So what I write. This approach should be begun early in elementary school. The facts are important in science. Without them, it is impossible to really comprehend knowledge. Curiosity is vital for ability to memorize. Curiosity nurtured together with learning, nurtured together with learning, keeps students with vital skills in graduate school and later in life.